Yeah, my name is Sergei. I'm a proud owner and part of the company that's called Texas Scientific Products. So there are 3 partners of ours, and my other partner is he's here and he's trying to make a video with me, which makes me very nervous. So the company is based out of Texas, but I'm based out of Massachusetts, and they're trying to drag me to Texas, but I just cannot survive there. It's not like I don't like Texas, I love it, but I just cannot be. I can be here from November till March. All right. So when we look at the nebulizers, the choice of these devices on the market is overwhelming. And why we decided to present it to you today? Either you have the ICP machine or you're going to buy one. But this expensive piece of equipment, from let's say high 60s to over 100,000, can be turned into the piece of frame, metal, and configuration of electronic boards in this little piece that costs maybe from a few $100s to $1,000 is not working right. It's as simple as that. And so that's why we decided to give you an overview and maybe you can learn something or we can learn from you as well. Please feel free, there is nothing formal here, it's a seminar, so you can ask me questions during the talk if you don't understand something or didn't quite hear well. So when you go, each of you have an ICP from different manufacturers. And you might have maybe some of those, you maybe seen them or maybe didn't. You're familiar with them or maybe they look completely out of whack for you. But this is just a brief summary of what's available out there. So let's try to make some sense of what's out there and see what works best for your application. So if you try to put some kind of a classification, so there is, most of the nebulizers are pneumatic, and we can have another type that we call special type, which not really in nebulizers, but they do similar job, which is ultrasonic, that's a nebulizer, but spark and laser ablation system, that's a little bit of a different, but they do, in a way, exactly the same job. So they do the sampling, and they transfer it from the sample to your ICP, to the analyzer. So just spark and laser do it from the solid material, while everything else is from the liquid. Now, when you go to pneumatic nebulizers, and pneumatic is called because they have to work with a gas. So the nebulization efficiency comes from applying a gas pressure. So there are 2 major types, concentrics and non-concentrics, and that's very important. Under concentrics, we have a whole group of nebulizers that you may or may not familiar with, which is mine-hard, conical, sea spray, or aerosol. So these all similar type of nebulizers, but made by different companies. And concentric is probably the most common and still widely used nebulizer on the market. And this is where it came first with some of the first ICP machines, but it's still being used, and then we'll let you see what was the reason. Maybe it's just inertia of our thinking, or maybe there is a real reason for that. Under the concentric, there is a low flow nebulizer that provide you with a low flow, which mainly useful for ICP-MS, which can live a little bit outside of our talk today, but can be used for ICP as well. Now, on the non-concentric types, there is plenty of types. Babington, V-groove, cross flows, gem-tip gem cones, Bergner, modified Linty, and a few nebulizers, Optimist, Optisols that made by our company as well. Now, if you look at this, does this sound familiar to you, of any of you? What do you think just by looking at this? Is it similar nebulizers or completely different? Just wild guess. Similar, looks similar. See, this is very tricky thing. They do look very similar, completely different. Completely different performance, completely different expectations. So the reason I brought this up is, so sometimes we ship one of our nebulizers, and people receive it and say, well, Sergei, but this is look concentric to me. It looks like concentric, but it's not. It's completely different, and we'll see it after. So what type of application? I picked up some of the probably most difficult ones that we see on the field. And we start from, since it's a petrochemical show, so we start from wear metals in used boilers. That's one of the very common applications that people run. Then there is additives in oils. Although oils and oils present here, but requirement for those two completely different. Why? When you run wear metals and oils, the main thing that you're concerned about is to handle the matrix that may have some particles there, some metal particles from a used engine or anything like that. And the concentration there are relatively small or maybe in the middle range. So the precision or accuracy of this measurement is not that important as long as you see the trend. So this analysis is applied to diagnose whether the engine is about to fail. So whether you're looking at this, whether it's really, in reality, 30 ppm or 32 ppm, it doesn't matter as long as you see the trend. And as long as it starts to pick up, then you know that something is wrong. Whereas when you do additives in oils, that's a completely different thing. It's a higher concentrations, and the company that introduced additives to their product, they have to know exactly, very precisely and accurately, within 2% or better, because every fraction of percent costs them millions of dollars. So that's why this is completely different application, completely different nebulizers needs to be used, completely different requirements. Crude oil, similar thing to wear metals. This is just another petrochem product which used in the engines of the cars, ethylene glycol. Trace level analysis, that's another one. It can be used in any industry, in pharmaceutical, in environmental, in semiconductor, where you really need the detection limits. Maximum detection limits, that's what you're shooting for. Then what we call high salt, high TDS. One of the examples is fracking works. That's again an example from the petrochem. And environmental. Environmental can be industrial waste, it can be drinking water, environmental soils or sludges. And another one we brought in is agricultural soils. That's actually a pretty demanding application because it uses this special reagent that's called malic that extracts all the minerals or nutrients from the soil so that agricultural people can see whether it's enough phosphorus they put in, or calcium or magnesium. And it's pretty demanding on the ICP because of the nature of the reagent. It's pretty aggressive. Okay, so before we go into what nebulizer is for each application, so let's define what is TDS. As you can hear from application people of different ICP manufacturer. High TDS, low TDS. What TDS is? TDS stands for total dissolved solids content in the sample. And how it is defined? What is high? What is low? This is called relative, but the ballpark that you can have in your mind. If you get over, and some people, when we're talking to them, they say, well, what is your, you run high salt, high TDS? And they said, yeah, we run really high. I said, well, how high it is? Oh, we have 500 ppm of calcium, 100 ppm of sodium, 200 ppm of magnesium. Well, that's maybe a high concentration, but that's not really high TDS, as the terminology used by application chemists at ICP. Why? So 1%, if you go over 1%, which is 10,000 ppm, and that can be total. So then it started to get high. And again, this is, I just pulled this number, it's arbitrary. So there is no like strict rules here, but just as a ballpark. If you go over 3%, then, so up to that, you're probably okay with any nebulizer. If you go over 3%, you need to pay special attention to this, what you're running and how you run, not just the nebulizer, but the plasma conditions, plasma power, things like that. The tolerance to the amount of high dissolved solids depends on the elements. There is one thing when you have these guys here, sodium, potassium, calcium, magnesium, or semiconductor people, they may run these more exotic elements, and they're not going to have a problem with 2 or 3%. While if you put 3% sodium, then you're going to be eating your torch like no tomorrow. So that's all depends. Okay, so let's start with just going by design. So we selected one of the top nebulizers, one of the types is concentric. And under concentric, there is that's made by different manufacturers. Meinhardt, that can be conical, it can be sea spray can be something else. So what is the design of concentric nebulizer? Why it's called concentric? So you have a capillary, glass capillary that coming through the body of the nebulizer. It comes to the end of it, to the nozzle. So then, the gas orifice is, since there's a position, have a concentric shape. So this is your sample capillary. This is the annulus where the gas goes. So here's your sample, here's the gas. So it has a concentric geometry. That's why it's called concentric. When we look at the conditions of the analytical performance, it has great nebulization efficiency and precision, but it has a very tiny sample capillary, very tiny. It depends on the nebulizer, but it could be less than 0.1 millimeter. So it can run some particles, but only up to 75 microns. Millimeters, sorry, that's a mistake. Up to 75 microns. And so that's not a large particle. So every tiny particle that can go into this nebulizer can make it stop working for you. So what is the other advantage? Why it's so popular? One of the key advantages in the design of the concentric nebulizers is self-aspirating capability. So what is that? So when you have the nebulizer and you can run it without extra force from the peristaltic pump, it can self-aspirate. As long as you give it some pressure from argon or other gas, it will start to produce the aerosol, and that's what self-aspiration is. Here you can see without going into too much details. So you have a liquid coming in the center, and then you have gas coming around, and this is a cross section, so it's in a circular shape. So when the gas coming out with a high speed, it creates a low pressure kind of vacuum, in Curie effect, physics is called, and it pulls liquid and creates a spray. Then it mixes up with gas flows here, and this is where you have your spray. So why this is important? Because when you run the instrument or we run your nebulizer using peristaltic pump, even the best one creates pulsations. That's the nature of it. If you can bypass it by self-aspirate, your precision is going to improve quite dramatically. Now, there are some other devices on the market right now. It's not the peristaltic pump, there is so-called syringe pumps. It's a plunger that going back and forth very smoothly. But that's a quite expensive pleasure to have the separate piston pump. So that's why a lot of people whose requirement is precision use the concentric nebulizer. One of the examples is precious metals. In precious metals, again, as the additives and oils, you've got to have very top-notch accuracy, better than 2%. And having a good precision is one of the things that helps. is a bunch of type of concentric nebulizers produced by different manufacturers. So I'll just go quickly through them. So that's type A by Meinhardt, where the capillary is flush with the end, with the tip of the nebulizer, tip of the nozzle. So that's, according to manufacturer, is best designed for the best intensity. So then there is a type C and type K, which is kind of similar. In similarity here, the designers pulled back the capillary, or it's called recessed. So this type C is fire polished, and this is not fire polished. And this can be used with a lower flow. So this is the difference. Why this is being done? By moving the capillary back, it creates some space here, and it will slow down the salting process when you run high salts. That's what the claim of the manufacturer is. And apparently it works up to a certain point. So that's another type of concentric nebulizer produced by glass expansion. So that's the C-spray nebulizer. Again, it's a similar design on type C of the Meinhardt, but here the capillary is pulled back even further, and the nozzle is a little bit extended. So that will give a bit more tolerance, again, according to manufacturer. So the spec is you can run up to 20% of total dissolved solids. In other words, you can run 20% sodium chloride solutions for that. Particulate tolerance is still, because it's all of these are concentric, is still around 75 microns. Now, this nebulizer is made by a different manufacturer. It's called aerosol. It has a similar design to C-spray, but what is the difference between those two? This manufacturer machines the capillary. So every time they do machining, it's very reproducible. Versus this guy is hand blown by the glass blower. And glass blowers are a special breed of people, so they are very talented, they are very dedicated. But even best glass blower, he cannot compete with a machine. So this is more like if you get one nebulizer and put another one, it will be very close to each other. But in terms of the performance, they're quite similar. So I brought this slide back just for a second to show you that all of these are still concentric type. And there was a misconception. Some people say, well, the C-spray is not really concentric, it can run high totals of solids. It is concentric. It is still capillary, and it's still surrounded by the gas. Yes, it can run higher solids, but if you give it a real particle, it plugs. Now, what is with all of these designs that claim to run high dissolved solids? One of the key things here, none of these nebulizers will work successfully unless you use the device that's called argon humidifier. Why is that? I don't know. In Texas, probably it's not a place to talk about skiing, but I'm coming from Massachusetts, so I'm always trying to use this example when explaining it to people. So if you ever saw, maybe on the TV, snow-making machine, so you have a nozzle, and there is a water coming into the high pressure, and then when it spits out with a high speed, so water turns into the ice particles, right? So it becomes solid. Similar effect happens with the nebulizer. So when you look at this tip, so you get liquid coming in right here, and then it's getting pushed very fast. Yeah, liquid coming here, and the gas is around. So on the high speed, it will push it out and create a spray. And because of that, the liquid, especially if it's a high salt, will start to form crystals. Temperature drops, and you start to have crystallization here. Yeah, this design with the recessed capillary is going to slow it down, but it's still going to crystallize. It's just a question of time. So what is this guy will do? It will introduce a moisture into the nebulizer flow. So it's just a nebulizer flow comes here, And the water is not shown here, but normally, yeah, this is the entrance for the water. You fill it up with water, it goes and bubbles through, and then comes out, and then goes to the nebulizer. So this little moisture that being picked up on the way is enough to slow this process down dramatically. As an example, you may be able to run 20% solids within, for an hour or maybe 2 hours, depends on the nebulizer. If you put argon humidifier, you can go with a day. So that's the difference. So this guy is a must, no matter what, what says on the high solids and not high solids. Now, this is just to bring you up, a couple of things that, being all these high solids nebulizers, they're being concentric, in the design, so they require some maintenance. And this is just one of the manufacturer's offers. So in addition to the nebulizer, you would get the cleaning tool. So if your nebulizer clogged, so you can take this, fill it up with solvent, and backflush. Also, now recently it's been introduced inline filter. So you get a nebulizer, and then you need to get a couple of other things to make it run more reliable, right? But presence of this tool also an indication that the the concentric nebulizer is going to pop eventually. So this is just to introduce you to that's actually pretty interesting nebulizer. It's a very special thing. It's called DIAC, or direct injection high efficiency nebulizer. It's mainly used when you need to run high volatile organics. It has a very tiny capillary, and the shape of it helps to introduce it directly into the torch. So there's no spray chamber. So it has a very high efficiency, converts all the sample, almost 100%, into the aerosol, and it gets straight to the torch. So that's actually a pretty clever design, but it has some limited application. And just to mention, since it's also part of the nebulizers, it's ultrasonic nebulizer. It's very efficient, so it produces so much sample because of this efficiency that you cannot run it straight. It has to go through the so-called desalvator, where you heat it up to about 160, 180 degrees C, and then there is a cooler. So you cool down, and when you're cooling down, the solvent is getting condensed and removed. So your analyte is passing through. So all the extra stuff in the solvent load is going to be removed while your analytes are passing through. That's why you get a factor of 5 to 10 improvement in detection limits, depends on the configuration. But the downfall, it's a bit of a complicated design, and we found some differences in volatility between different species, at least for arsenic and selenium. Non-concentric designs. One of the most common one that was, at the beginning, in early stages of the ICP development, was the cross-flow. So this is where the argon and the sample are under 90 degrees. So your sample comes here, and your argon comes in this direction, and it sprays it up. So it's a very good generic nebulizer. It has a little bit of higher tolerance towards the particles, but it requires to use this coiled double pass spray chamber, which I'll show you later. It's a little bit, it has a large rinse out time. So this is one of the examples of the cross-flow nebulizer. It's made by Perkin-Elmer. It's called Gem Tip. So you can see this here, and you can see details. That's one of the nozzles for the sample, and under 90 degrees, I think it's made from sapphire, I believe. This is where argon is coming from. So it's also made from HF-resistant material, so it can be used for HF applications. But this guy has to be used typically with spelled double pass spray chamber, which we brought one of the examples to show you. And then later you will see this spray chamber, you will see the difference. So you can, pass it so people can take a look. So the difference is, you can see this big guy and this big guy. Yes, where you get a better washout. Here. Yeah, this is going to take you 2 or 3 times longer to wash it out. And then when you have a high productivity left, so that really gives a pretty big advantage. So when people started to, when concentric nebulizers were in place, but they were clogging, so researchers started to look at alternatives. One of the alternatives that was developed way back was Barrington design. And that's a patent where liquid just goes on the surface, and this is the source of the liquid. And this is just a principle. And the gas comes from here, so there's nothing to restrict it. And basically you can nebulize anything. So this is more of a practical realization of it, where the sample comes in. So then it hits the gas orifice here, and then it goes over the V groove that's in the shape of the V. And this V groove design, you can see in the further developments, but that's one of the, on late development, I'm sorry, this is one of the first designs. It runs without clogging. That's a big advantage of it, but it has very low efficiency. So the detection limits are not good at all. So this is one of the examples that actually I used to work with back 30 years ago. That's great. So that's a GMP type nebulizer made by, I think, one of the Australian companies. It has like impact ball. So the sample comes here, there's a little bit of a big groove, and then it sprays it out, and then there's impact bead or impact ball, so where it helps to break down the aerosol droplets to the small one. The efficiency is improved, but it's still not as great. This was done again to, so the people trying to get away or find the alternative to the design of the concentric nebulizers. But also what happened when the concentric nebulizer, the one by glass expansion, was introduced to the market. So they also around the year 2000 came up with the cyclonic spray chamber. And that was a big thing because it allows to increase the productivity by reducing the washout time dramatically. So if we look at the numbers, and I just still, even today I talk to people who are still using cross-flow, Scott double plus spray chamber, so they at least rinse for a minute and a half. So when you get to cyclonic, you can get to about 30 seconds, 30 to 40 seconds. But since then, people started to standardize and came up with a standard of 6 millimeters, and that's what most of the nebulizers are now being made, to be able to feed the cyclonic spray chambers. So we started with old Barrington V-groove nebulizer that look like old school, and this is more modern designs. So this is V-groove by Thermal. This is the inert V-groove nebulizer by Edgerton, but this guy also, it doesn't work with cyclonic spray chamber. It requires so-called Sturman master spray chamber, which is kind of similar to Scott double pass, but it has a little bit of a variations here. And it's also quite expensive. And this is another version, that's a V-spray by glass expansion. It's a ceramic nebulizer. So all of these have the V groove, and they're not concentric. So that's why we kind of put them together on one slide. So this is also V groove nebulizer, but it just didn't have enough space on one slide. So that's why I put it separately. So that's what's called gem cone. It's a high dissolved solid nebulizer, or HDSN by Perkinol. So you can see here. There's a cone, that's opening for the sample, and then there's a little bit groove, and then the gas comes right from here. So it feeds into the cyclonic spray chamber. Perkinol recommends it for tough applications like used oils, high TDS. And again, based on, I'm not here to criticize it, but I need to mention a few pros and cons, and basically what we hear from the field, it's still quite low efficient, and the precision is not great. I mean, it's okay, but not great. Now, this nebulizer, maybe you either you haven't heard or maybe not familiar with. It's not that common, but this is actually a pretty good option. This is another non-concentric type nebulizer that's called modified Leikin. And it's been on the market for a while. So we redesigned it and we introduced the version that we call E-square or enhanced efficiency modified Leikin nebulizer. It has the sample pass that's right here on top that has an opening of 0.5 millimeter. So imagine the concentric is less than 1, so this is pretty large. And then at the end there is a hook, or what we call striker. So when the sample comes in, it hits this hook and then it comes down and then it meets with the gas that's coming from the argon channel and then it sprays out in the tangential direction. So it kind of, when you put it in the spray chamber, it goes around the circle and creates a very efficient aerosol. So this nebulizer is good when you really need to hit detection limits because you get an improvement as compared to concentric on average of 30 to 50%, maybe a little bit more. Okay, so by the way, while I'm talking here, I'm going to pass. Yeah, this is just one example of concentric nebulizers. So you can look how tiny it is. Now, this is very common nebulizer nowadays, and that addresses the clogging. It has a non-concentric design. It has a family of what's called Bergman nebulizer, and it employs parallel path. So what parallel path is? You have the sample coming in through the channel here, and then you have a gas coming in parallel. So then there's a little bit of a hook here, and the clever design lets liquid go by the surface tension and come out through the spout into the gas stream. And then from there it gets sprays out and you get aerosol. So the diameter and the shape of the orifice is actually pretty interesting. It's not round, it's done on purpose. And this is just a comparison between concentric, which is around 0.1 or 0.2 here, versus 0.5, 2.5 times larger on Bergman nebulizer. So its diameter is 0.5 millimeter for the version that's called mirror mist. The other version has even larger diameter of 0.75 millimeters. It can be made with a PEEK from PEEK, which is polyethyl ketone, or Teflon. There's a certain differences between these two materials. PEEK cannot be used for highly concentrated acids and solvents. Teflon can be used almost for anything. In my view, the best application for this nebulizer, in addition to being tolerant to particulates, is to be HF resistant when it comes to Teflon. So this is the nebulizer that we recommend to have HF resistant application. That's the guy to use. And of course, high salt tolerant. Now, what downfall of this, may be a little bit pricey. So you really need to know if you really need. That's why I highlight HF, because if you don't run HF, then you may be, better with a less expensive version of some other nebulizers. Also, one of the things that in the manual is, that's how it's written in the manual, do not touch the tip. So this is made from Teflon, one of the versions. And the Teflon is very soft. So this is one of them. So apparently if you touch it with a finger, it's gone. The performance is gone. That's manufacturing. Okay, so then we looked on all of that, and actually my partner about 8 years ago, he was walking into one of the labs that runs agricultural soil analysis. And he walks in and he sees a whole cemetery of the nebulizers that's not in use. Each of them about $800 was a cost. So when you look at this and then come back and say, well, there's something wrong here, we need to do something about it. And then we started to see, and we knew at that time we were working for the ICP manufacturer, and we know there's a bunch of choices, but when we see that, we realize, well, besides all these choices, there's nothing really there, the rest is, each particular. So we started to look, and we came up with this concept that we want to build one concentric design that can handle, be tolerant to high dissolved solids, and be able to be tolerant to salt, high salt matrix, and also feed this iconic spray chain. It has to be simple, reliable, and also one of the important things that we see, labs, regular labs, should be able to afford. So the design that we came with is non-concentric, and I'm going to pass this nebulizer that you can take a look at. It's a non-concentric design. So the sample comes here, and it has unrestricted channel of 0.5 millimeter. So the argon comes from the bottom, and it has this spot right here. And see, they a little bit tapered together. So, and then it goes down. And we've also made a V-groove, although it can work without it, but with V-groove it works a little bit better, and then it sprays out. So very simple, very straightforward, and it works with cyclonic spray chain. 0.5 millimeter diameter gives an ability to handle particles up to 500 microns. There's no clutter. So that's one of the pictures of it. That's an operation running oils on one of the instruments, one of the customer sites. And then I'll give you a couple of, we need to already finish, I'm sorry, maybe to get over. Give you an example of applications. So this is the scans, or spectral scans of lead in coolant, or ethylene glycol. And ethylene glycol is a mixture of water and organic. This is the scan from the nebulizer, and I want to give exact name so we don't want to hit on the manufacturer. So that, but this is a very respectable manufacturer and very common. So when they make the scans, they can see this, and it's 10, 5, and the purple line is 1 ppm. So when they got Optimist, they clearly started to see this little peak. See that? They can see that, and they can analyze it. Here, they have almost nothing background. Surprisingly for us, this nebulizer also would give a very decent precision. Because normally, the downfall of all V-groove designs are lousy precision. So we get it to people who run additive in oils, and so this is the curve and some of the data they've got for phosphorus and sulfur. So they were pretty happy with that. So it works pretty well for additives as well. So the precision is very decent on this nebulizer. So then we made a step up. We came up with a nebulizer that stepped up from the design of the Optimist. No, I forgot it, sorry about that. So where we made the capillary that can go up to the sample channel up to 2 millimeters. Normally it's 1, it's a standard size, and it can be custom made up to 2 millimeters. So we have a customer who's plugging everything under the sun. Badminton, burner, you name it. So then we give him Optimist. We managed to plug that. But he really running it. He's really running a mod. It's a conglomerate of particles. It's like a black sample. So then we gave him this guy, and we increased the sample channel to about 1.4 millimeters. We don't hear from him in a week. In about a month, he calls us, Sergei, can you send me another one? So this nebulizer now used for this special application, we can run industrial waste, when you have a bunch of particles. You can do weigh metals and oils as well. You can do pharmaceutical, blood, serum, slurries, anything under the sun. Yeah, this is here. We can skip that. They just, our marketing people just tell me, well, see who we are, what we do, but we can skip that because we ran out of time. Okay. So any questions? Well, thank you for your attention. Thank you. Stick out with me in this last minutes of the Gulf conference, and now we're going to be facing this traffic and everything. But I'll be happy to answer any questions. So at least it will look like we have a seminar, not just a presentation.
Are there any drawbacks on the optisolid nebulizer? I know you mentioned some other ones.
Yeah, of course there is a drawbacks. Well, any non-concentric nebulizer will not have the best precision. And there is some loss in sensitivity, but the OptiSolid is actually a little bit more sensitive even than the Optimist. So it's going to be a little bit below concentric, but comparable to the crossflow. So it's definitely a step up, like all the designs, and it doesn't have a V-groove as well. At the beginning, actually, when we started to make it, it's called, our production people called it V-groove-like, VGL. So, because it should have a V-groove, but the way we manufacture it, it works good without it. So why bother? So yeah, on any of the V-grooves, yeah, there is no miracles. You will lose a little bit of sensitivity. The question is how much. Like today, I just talked to one of our customers, and he runs the C-spray, he runs brands, well, 20% solid. And it works fine, but C-spray clogs, right? So then we started to talk, we said, well, maybe we give him Monlichty, and then when he said 20%, for 20%, Monlichty is so efficient that it will shut down the plasma. So this is not right nebulized. Then I suggested, well, why don't you try OptiSolids? It will be a little bit less sensitive than the C-spray, but maybe in about 15–20%. And if that's going to be enough to get you through the action limit requirements, you're not going to have any trouble. So that's the comment. The cost? Everything is okay. The Optimist is under $500, $495 or something like that. With all the connections, it may be 505 for Spectrum, but general configuration with this type of fittings, which is, with the snap-on connectors and stuff like that. So it will be ready to go on any of the instruments. So with all the connections included, it's under $500. The OptiSolids is a step up. I believe it's $565. But it's no way near $1,000 where all the Teflon nebulizers are. I didn't put too much. Of course, there are some Teflon nebulizers from the other companies, and they work quite fine. But in my view, if you don't run HF, or if you don't run very pure replication, like in semiconductor, when it's extremely important, it's overkill. So you're basically paying for something that you're not going to utilize fully. Okay? Will it work? Yeah, of course it will work. People running, burner and microflow and whatever PFA nebulizers, they running application. But if the HF, or if you don't require high purity, it's like you're running a Porsche on the dirty road, instead of having a regular SUV when you need to go through the mud. So that's where the difference is. So we trying to price them that they are very competitive, and that was what we kept in mind. That's why the cost of this is where it is, because it's very simple design. Is that complicated? Some of the nebulars you see here, yeah, it will be in the range of $900,000, like with the other guys. Yes, you want to keep it?